Okay, so today's session we will be discussing about what an interrupt is. In the previous class we had discussed what a memory map is, what is a direct memory access. Now, what is an interrupt? So interrupt, as the name suggests, it is trying to stop something that is currently running and it is trying to complete its work. Okay, so there are different there is a programmed IO approach where the processor is continuously busy. Okay, and you can either have it executing the program related to the IO devices from the port, and it waits for the input ready. Like say, if it is an IO device, you need that IO device to be ready, or the output process to be completed. Okay, or else you can have related to the devices. The devices in the sense the devices that are connected, the peripheral devices that are connected to the system. So it waits for the device to get ready, the device status ready, or the completion of the function. Okay. So there are two types of words which we need to be familiar with when you talk about stopping a process and running the interrupted process. Okay, so there are two words. First one is a polling. Second is an interrupt. What we are going to discuss. So both these polling and interrupt. So both are actually they are events which are generated by devices. It can happen any moment while the CPU is busy while executing another process. Okay, but what's the exact difference between a polling and a protocol? Polling and an interrupt. Okay, so polling is actually the first main difference. Polling is a protocol. Now, example, it is like say you are actually waiting for someone. Okay, and you are like so always anxious. Okay, you are anxious, you are excited. You always go and constantly open the door, no matter whether the bell is rung or not. Okay, it means that see, even if the person is not outside, you are actually going on looking. Okay, that is known as what? That is known as polling. Okay, that is at regular intervals, the CPU keeps on checking IO devices whether there is a uh, process to be executed or not. So it weighs the CPU cycles. It is actually done by a command ready bit. Okay, and CPU provides the service. Okay, CPU service the provides the service for the polling. Okay, CPU is the one who does the polling. In the case of interrupt, it can be hardware generated or a software generated mechanism. Okay, so it is like you are waiting for the person, but you're not going to check it unless and until the person is ringing the bell. Okay, so hence you don't waste the CPU cycle as much. That is, you get an interrupt to the CPU by the IO devices through the interrupt request line. It can happen anytime, but in contrast to the polling, okay, it is handled by the interrupt handler. Okay, and yeah, it disturbs the CPU efficiency because if say you might have studied trap request or all such of there are priority based in interrupts. So if the CPU is doing a work and an interrupt comes based on priority, it may be halted if the interrupt flag is enabled. Okay, and so what happens? The CPU system will halt the current work and it will go to complete the interrupt. So it disturbs the efficiency, but it does not waste the CPU cycle. Okay. Now this is how to give you a more clearer picture about what how an interrupt service routine can be. Okay, your program is constituted by a different n number of instructions. Okay, you have instruction one, instruction two. So you can see the program flow in the arrow like this. Okay, so at while executing the instruction four, what happens? You get an interrupt. So what it does is, so you will study more in detail what is going to happen there. Like say, you will hear the word known as context switching when you study the RTOS system. Okay, but still, in a brief way, we can say that whatever work is done currently, it has to be saved to the stack. Okay, because the interrupt has occurred, so naturally, you have to complete the interrupt But after the interrupt, you have to come back and resume what you have done. So naturally, there need to be a data to resume. So that data is saved onto the stack. And once it is saved onto the stack, the system goes to execute the interrupt. So interrupt may contain some certain programs. Interrupt also contains certain programs or certain instructions that is to be done. So maybe by the fourth instruction, the interrupt may be complete. So you have a routine for that. Okay, that particular program is known as an interrupt routine, ISR. You might have heard about interrupt service routine. So after that, it will come back to the point where it was executing prior the interrupt has occurred and complete the program. Okay, so that is how the interrupt service routine works. Now, what is the need for interrupt? No, the need for interrupt is, say, while you are writing a text document, you are writing Word. What do you use to write? You use your keyboard to write, right? So you in your keyboards you have different keys. So if at all you don't have any interrupt, so the key pressed, the key up, all these events may not be recognized. Okay, when you press a down arrow, the cursor has to move down the document. When you press an A has to come, the ASCII has to become. So all these are interrupts. Okay, so if there is no interrupt, it won't be useful for the peripheral devices. Okay, so where you need to write or read the data from or to an externally connected device. Okay. Types of interrupt, you already know, we have encountered them in 8085, the microcontroller. Still, you have hardware interrupt, say like the key press. It is an electronic alerting signal, okay, sent to the processor mainly by the external device, okay. Like say you have your keyboard, you have your printer, disk controller, external peripheral, okay, all these things, okay, a mouse. So when a device or port is ready, the device generates an interrupt, okay. So usually the hardware interrupt generates the call to the interrupt service routine. So what program is, so the ISRs may be saved in the location in the external memory. So the call will be generated to that particular ISR and the hardware interrupt is run. Same way you have software interrupts. So software interrupts are programs. Okay, they can be generated by either when you are say doing an arithmetic operation, say like you are dividing by 0, or when you have an overflow, okay, or there can be an illegal opcode, okay. So when things like that occur, it means it is an exception, okay. So at that time, an interrupt is uh, received, or else you can have the INT instruction. In the case of your 8085 and 8051, you have INT instruction, which is followed by 8-bit word, 8-bit number, which indicates the type of interrupt. Okay, you might have seen in 8051 you have different types of interrupts. Okay, type 0 to type 255. Okay, so and all those interrupts will point to a particular location in your memory. Okay, which is known as the interrupt vector table, where the interrupt service routine is present. Okay. So that is what we are going to discuss now, the interrupt service routine. It is, in short form, it is known as the ISR. So it is actually a software, it's program which is invoked by an interrupt request. Okay, from it can be a hardware or a software. Okay, so it handles a request in the sense whatever that request is, whatever has occurred, whether it's a key press or whatever it is sent to the CPU by interrupting the active process. As we discussed, when the ISR is complete, the process is resumed. So let us say we have discussed the example, but still the example is, say you have a routine keyboard event. So the ISR makes the system understand that whether it is in a key down state or whether it is in a key up state. Like say when you are continuously pressing R and you are in a Microsoft Word document, the word R keeps on coming unless and until you takes up the key. You remove your hand from the key. So that means that a key up event has occurred. So in other, you can call the ISR as a signal handler or a trap handler or an exception handler. Okay. Okay, this we have already discussed. So there is a when a interrupt service routine occurs, it points to an address location which holds the interrupt service routine. So that table is known as the interrupt vector table, which holds the set of address. Okay, so it holds the starting address of the interrupt service routine, and the interrupt goes on getting executed unless and until a return from interrupt is encountered. Okay, always an interrupt will have a starting and an ending. Okay. Okay, starting is indicated by the starting address of the interrupt from the interrupt vector table, and end of interrupt is indicated by a return from interrupt instruction, RETI instruction. Okay. Now, there can be multiple interrupt occurrences. Okay, like say you press multiple keys. So usually that is based on either the nested approach or based on whichever is a high priority. Okay, so that is how the system handles the interrupt handler handles. Okay. Now this is a pictorial representation of how an ISR can work. So you can see the main program. Okay, main program is running, and you get an interrupt in time. So what happens? It goes to execute the interrupt if it is a high priority. So likewise, at different times when you get the interrupt, the main program is halted and the interrupt is executed. Okay. Now ISR, mainly the execution is done in two parts, which we are not familiar with. Okay. So usually there is a critical part which is related to the hardware. Okay, and also there is a long service routine. Okay, so the critical part is done by short execution time. Okay, critical part in the sense a part which deals with the hardware. Okay, so this is a device dependent handling. Clear. So it does the functioning by passing a signal or message to the OS. Okay, so now long service routine, what it does is it waits for the hardware part, the critical part to be executed, because this is of lesser priority interrupt. Okay, so the OS schedules the interrupt service routine as per the priority, and this is the software part. Software part is a device independent type of handling. Okay. So this is an example how an interrupt execution works. Okay, say you have two events. Okay, during those two events you can have interrupt coming. That interrupt coming is indicated by interrupt service threads, IST thread 1 and IST thread 2. Okay, now what is a thread? You will be learning in your fifth module RTOS, but still to make you understand, in embedded system we call the real-time programs as tasks. Okay, so tasks can be a group of instructions, okay, which perform a function. So it can be divided into smaller parts. Okay, a task can be divided into smaller parts which are known as threads. Okay, so that is what a thread is. Okay, so you can see an event comes. So what happens? The uh, interrupt service routine, what it does is it reads that particular address and what the previous event it is saved, and the signal that it signals the CPU to execute the interrupt service routine thread 1. Okay, and it completes the interrupt service routine thread 1 and goes back to the event and it completes it. Okay, so that is how the event 1 and event 2 is done. Okay. Say for example, when a camera start key is pressed. Okay, so at that time what happens? You are reading an analog image, it has to be processed, so it is converted into pixels. Okay, so you have the ADC, so ADC starts the scanning from the first to the last pixel in the row, and for dark, it finds out the offset values. Okay, Then the signal task, it reads the frame pixel from each row thread. It repeats step 1 and 2 until the last row is encountered. Okay, so that is how ISR execution works as an example in your camera. Okay, so when we talk about different examples, one example is the ACVM. ACVM stands for the automatic chocolate vending machine. Okay, so automatic chocolate vending machine, you might have seen, you insert a coin based on that amount you have entered, the chocolate of that particular value, you receive it through a opening down. Right? So now this is a programmed IO transfer type where it is working based on an interrupt. Okay. It does not work like a system parallel to where a processor runs. It is not like that. Okay. It is based on a coin sensing, then key press. Okay, such sort of event. So it is a naturally event driven or interrupt driven type. That is, device is activated on each interrupt after sensing coin inserting event. Okay. So this activates the system, okay, through a hardware or software signal. And what it does is it collects the coin by running a service routine. Okay, it collects the coin and reads the value. So there is an interrupt handler routine for a coin read port. So this is the pictorial representation of what can happen where the coin event has occurred. So at that time, the system is triggered and it calls to the ISR for coin reading. Okay, and then it resets the port again so that it saves the amount of memory, because all these sorts of embedded system machines, they have very less memory. Okay, so another type of example is a digital camera where we have already discussed that. Let's say you have an image, the system awakens from an interrupt from the switch when you're going to have a click. Okay, at that time the device grabs a image frame, and that image has to be processed by converting it to digital format, which is done by the ADC. Okay, so this we have already discussed. So same way you have a mobile phone, there are many applications. There are many features in a mobile phone like Bluetooth, USB, Wi-Fi. You have micro SD card feature. Okay, so if at all you have a system reset key, what the system reset key does, it brings the mobile phone back to the, you have factory reset and you have hardware reset. Hardware reset, it deletes the entire data in such a way that the system is like a new mobile phone. Okay, so it resets the system to a initial state. So what happens when such an interrupt occurs? So there is an ISR which is associated with the interrupts, reset interrupt. It suspends all the activity of the system. Okay, so either a reset. What is the condition that you will be applying a reset to? When either the system is in a hanging condition or there is some problem with your device. Okay. So what it does is the current activity will be suspended. It sends signal to the display function and program thread for displaying the initial reset state menu and the graphics on the LCD screen. Also, it activates display of timer for 15 seconds timeout. So that's an example. Okay. Then after that, the system awakens and activates the interrupt through internal hardware signal. And also it runs another ISR to control bit to the LCD device. Okay. So that is how the reset works. So this is an example which shows you how the ISR for a reset interrupt works. Okay, so it on encountering the reset interrupt, the it calls the interrupt service for the reset key. Okay, and it reads the current state from the ports and resets all the state bits and sends message for tasks to be suspended, and it signals the timer for enabling display off after 15 seconds. So this is how interrupt service routine for resetting your mobile works. Okay, so with this we come to the end of interrupts.